Good morning, everybody. Welcome to another exciting morning of Chem 1211 with your host, me, Dr. White. By the way, when I get in front of a web camera, I found out Dr. White becomes a wild and crazy guy, but I'm still an organic chemist. All right, a couple important things. First of all, I got a number of emails from people who are concerned, oh, they're going to ship me the code for Lab Z. You don't need it this week. And actually, next week, you sort of need it by Friday. So you have plenty of time, or Thursday if you have lab on Thursday. By the way, tea, vanilla, second cup, so that means it's blueberry from the Republic of Tea. But anyways, also, if you're in section one, VCM 01, I'll call rest of the semester that's section one. And if you're in section two, VCM 02, which the rest of the semester I'll call section two. Section one will have lab tomorrow and it starts at 9 o'clock, not 10. And on Friday, those of you in section two, notice I'm ambidextrous. Ooh, it is getting to be awfully humor Wednesday. But anyways, you'll have on Friday at 9 a.m. And please go to the section you're supposed to go to. This week in lab, I will be going through the basics of Lab Z. So if you're concerned about it, are you doing it right? If you don't have it yet, relax, take a deep breath, let it out, take a deep breath, let it out, relax. You don't need it this week, but I'll still show you. And also feel free after labs anytime or in my office hours to ask questions. I can show you how to do anything in Lab Z. And don't forget, speaking about office hours, tonight from 6 to 7:15 at the Zoom meeting login that I have in my syllabus and also on Blackboard, I'll be having an office hour, actually office hour in 15 minutes. Stop by if you have any questions. All right, time for a public service announcement from your host, me, Dr. White. Don't forget, four main branches of chemistry are organic, inorganic, I'm not a big fan of inorganic, physical, analytical. The best one is organic because Dr. White's an organic chemist. But public service announcement. One day I started talking about chemical symbols and said you should learn these. And I mean it. You should start now. You should know H is hydrogen. So on a test, if I put down, give the name of the element with the chemical symbol H, you should know that's hydrogen. If I ask what's the chemical symbol for the name of the element with K, that's potassium. If I ask, give the chemical symbol for bromine, it's Br. If I ask, give the chemical symbol of krypton, it's Kr. Ooh, by the way, unless I've been hijacked to another universe, the element krypton in our universe is not a green solid that will kill Superman. It's a colorless gas at room temperature. But I can't emphasize enough, you should start practicing this now. I only asked you to learn 37 of them. Example, AU is gold. The most important one for Dr. White, C is carbon. Now, personal story. A couple of years ago, I was driving around in the area and stopped at a stoplight. And as I tend to do, I was looking at the license plate in front of me, and I saw this on the license plate. Actually, they're all caps, but think of this could have been AG. And it took me about 2 seconds. I started laughing and said, that person's cool. And now it's time for Dr. White to do a generation gap thing on you. What does this stand for? On the license plate, Hi Ho Silver, AG Silver. And for those of you who don't know, that's from the Lone Ranger. By the way, the Johnny Depp Lone Ranger movie was the most disgusting, awful thing in the world. I only saw the trailer and knew, I don't want any part of that. For those of any of you, which I doubt any of you, but for my generation, when we were 5 years old, the most popular show on TV, or one of them, was the Lone Ranger show. And it always started out the same way. And it would say, Hi ho silver, away. And that's where that got. By the way, my license plate is DR space KW, Dr. Kenneth White. And I'll tell the story not now, but years ago, I was heavily involved with the Democratic Party of Chicago and helping out on one senator's campaign. Uh, he said, What can I do for you? And I said, Give me money. He said, I can't do that. I said, Well, what else can you do for me? And I didn't want a job with the city or state, so I had a nice paying job in chemistry at the time. So he was on a state committee that are about to announce personal license plates, and Dr. White got one of the first in the state. I had my choice. All right, let's go back on. Let me just clean up stuff. Let's go back to chapter 2. I was talking about scientific notation. Thumbs up, people. And can you turn your video on so I can see your faces, if you don't mind? And hopefully everybody sees scientific notation on. If you don't want to turn on your video, use the emoji sign. Everybody see scientific notation? Thumbs up, thank you. I'm gonna be contacting Zoom about changing things so you can tell you really changed it. So scientific notation is when you have a number n between 1 and 9.999, never less than 1, never 10 or more, times 10 to the nth. And you can do that. You can show a large number using scientific notation. And we practice that. And hopefully everybody sees my whiteboard now. Thank you. If not, yell out. And the question is, write the following in scientific notation. Well, you look where the decimal point is, or if there was a decimal, I'm going to put it in, and you move it to the right of the first non-zero integer. And how many times did I move it? 1, 2, 3, 4, 5, 6. And Justin, did you have a question?
Okay, I just couldn't see the whiteboard.
All right, thank you. That's the
I didn't
problem.
want to interrupt, but I couldn't see it.
Hold on. Now do you see it?
Yeah.
All right. And that's why I have to do the thumbs up, because Zoom told me you should be seeing it. And that's a bug in Zoom that I'm going to try and get fixed. All right, everybody see the number? Good. You move the decimal, if there was one, which there wasn't, to the right of the first non-zero number. Hopefully you all know right from left. If not, come to my office hours and I'll teach you. But anyways, Dr. White never assumes anything. I've moved it 1, 2, 3, 4, 5, 6. When there's no decimal, which there wasn't, you drop the zeros at the end. That would be 3.45. Then remember this is z times 10 to the x. What's x? When the number is greater than 10, x is positive. It's how many times you moved it, and that would be 6. And that's how you do it. Now, one of the things you can feel free to do, but I do rhetorical questions a lot in this class. And now it's time for me to share some of the fun. why don't you write this number in scientific notation yourself? Have some fun. Ooh, I get to see everybody. You're real people. And when you're done, give a thumbs up or smile if you have your video on. Now, normally, if we're in a class, I'd say, when you're done, look up and smile. I see all those smiling faces in my class because I know you're having a good time with chemistry. Don't forget, I'm an organic chemist, so I'm biased. All right. Anybody need more time? Nope, I think everybody's done. Let's do this. All right. How do you write this in scientific notation? And if it was on a test, I might write 3 points each. And in the classroom, you'd have to wait while I'm writing this on the whiteboard. Now, on a test, I wouldn't abbreviate, but I'm lazy on a whiteboard, so I do. If there was a decimal here, we'd move it to the right of the first non-zero integer. So it's 1, 2, 3, 4, 5, 6, 7, 8, ooh, 9. That's a big number. 6.3, when the number is greater than 0 and there's no decimal at the end, you drop the zeros. 6.3 times 10 to the 9th. Now, when the number is less than 0, you still move it to the right of the first non-zero number. And here's my decimal, 1, 2, 3, 4. And if there are any zeros at the end after the decimal, at the end, not the beginning, you keep those. In this case, no. So this would be 4.53, 1, 2, 3, 4 times 10. Now, when the number is less than 1, this is the symbol less than, it's negative. So that would be -4. And why don't you try this one? Write the following in scientific notation. And thank you for all turning on your video. I can see your beautiful faces. I see some beard people out there. I'm a beard person. The last time I fully shaved my beard was 2 weeks before graduation, actually 6 weeks before. Last time I fully shaved was right before high school graduation, and I have never shaved fully again. I've had a beard ever since. That's a long time. All right, I think everybody's done. Dr. White got to look at all my students. Here's our decimal. We want to write this in scientific notation. Say this were on a test. This would be an example. You move the decimal to the right of the first non-zero number. 1, 2, 3, 4, 5, 6. Notice I moved it 6 times. And notice there's a 0 at the end. It's after my decimal, so I keep it. And since I moved it 6 times, this number is less than 1. It's a minus sign, so that'd be 3.710 times 10 to the -6. And that's how you do scientific notation. Remember, you got to keep the 0 there. And that's why we practice, so you know how to do it right. And we just did doing decimal scientific notation. And we just practice converting from decimal to scientific. Now, for when we used to have things where calculators didn't do this, like if you had a slide rule, which none of you don't, Dr. White does, maybe tomorrow or next Monday, I'll bring my slide rule from college. That was my high school graduation gift, a beautiful gift, back to, I see a question. Question, is chapter 2 posted on Blackboard? And the answer is yes. Quick time to stop. Right now on Blackboard, and that's a good question. Remember, in my class, all questions are good questions. In my life, there's no such thing as a dumb question. All questions are good. On Blackboard, in the lecture folder, I have all my lectures for the whole semester. In the practice problems, I have the whole semester. Oh, I like that. The whole semester of practice problems. And I also, once more, and I hope try not to overdo it, I have all the practice problem answers. So those are all there. If not, let me know. Somebody got into my folder and deleted things. No, they didn't. But anyways, thank you for your question. But if you're doing math with exponents, this is important. But for my class, since all of you have scientific calculators, you don't. Speaking about that, it's in the syllabus. You need a calculator. This is, and I put it in my syllabus, the TI-30XIIS. And I looked the other day, they're available, and I don't get any kickbacks from these companies. I wish I could, but you can get them at Staples, Target, Walmart, just about anywhere they sell these. Don't get it. They have some, be careful, that are cheap, like $8, but they're used. I would never buy a used calculator because these are about $16, give or take $1, which by today's standards are cheap. Generation gap thing. When I was in grad school and the first hand calculator came out by HP, it cost $500. Yep, $500 for a calculator. In fact, I knew one of the grad students who bought one, and we all, ooh, let's see it. Why did you spend $500? Now, back then with salaries, today 500 then would be worth a couple $1,000s. See how prices have come down. Oh, I just did another generation gap thing on you. All right. Now, one of the things I used to do was have students learn how to go from scientific to decimal. So I realized I don't do it. You're not going to do it. Why should I have you learn that? It's a waste of time. Dr. White lives in the real world and doesn't like to waste mine or your times. So let's move on. And thumbs up, people. Can everybody see measured numbers on your screen? Thank you. All right, now, when you take a measurement, you get a number. And that could be a weight, length, or temperature, a whole lot of other things. Now, it turns out there's uncertainty in every measurement. And in any measurement you make, the last digit is always uncertain, but only uncertain digits. It's the only uncertain digit. Let me do something that I didn't do before, but I'll do now. Murphy's Law when I was looking for something I found the other day. Now I can't find it, so I'll just wing it. All right, let's say you had a ruler and it measured in only inches, and you measured a piece of rope or string or whatever, piece of paper, and it only measures in inches, 1, 2, 3, 4, and you measured it, and it was halfway between 3 and 4. And you say, well, is it 3, is it 4? Well, it's halfway, I'll call it 3.5. And that 0.5 is the uncertain number. Now, let's say you have that on a different ruler and it now measures in quarter of inches. And now you can see 3.14, 3.5, 3 3/4. It was right on the line with 3.5. And you say, well, that's 3.5. It's right on that line, 0.0. And the last one would be uncertain. And significant figures plays an important role in our daily life. You don't think of it, but it does. You'll find it in contracts, legal contracts, in patents, and many other things. And probably next Monday, I'll find that example or email it out to you, a link. So when we talk about significant figures, and I'll never ask you what is a significant figure, but I will teach you how to use them, and that's important for you to learn, which we'll do this morning. Significant figures are the digit in any measurement that are known with certainty plus one digit that's uncertain, the last one. Now, there's another type of number called an exact number. And exact number are numbers obtained by counting items or from a definition. Therefore, an example of exact number is if we were in a classroom and I'd say, how many students are in this room breathing? And you couldn't say 48.5 or 46.5, because how can you have a half a person who's breathing? You have whole numbers. When I'm counting people, that's an exact number. If we're at COD and I asked you, go look out in the parking lot, how many blue cars do you see? Well, you're not going to see 5.5 or 5.25 blue cars. You're going to see whole cars. So the answer would be an exact number. Now, the other thing is certain formulas, which I'll be teaching you. Those are exact numbers. So you have two types of numbers. One is significant figures, a number that has significant figures, and another number that is an exact number. Now, if I were to write a number, two numbers on here, which I will, let's call this A and B. A is 5.30, B is 5. Those are different numbers and they represent, if we were measuring something, different accuracies. One of the things in life, the more significant figures of a number, the more accurate it is. Now there's rules for determining how many significant figures is in number A and number B. And let's go through these rules. You need to know these. Uh-oh, it's subtle time. See, everybody, how subtle Dr. White can be? And first of all non-zero numbers are significant. So if we look at B, there's only one number and it's non-zero. So B has one significant figure. Again, all non-zero numbers are significant. Now, zeros may or may not be significant. Wow, that wasn't too helpful. So is this zero significant or non-significant? Don't know. Lead zeros, I see a question. Thank you for answering. Again, Dr. White asked a lot of rhetorical questions, but if you want to answer in chat, feel free to. Now, lead zeros at the beginning of the number are never significant. Let's put an example up here, C. For this number, 0.00576, if I were to ask on tests, how many significant figures does this have? Well, all non-zero numbers are significant. 1, 2, 3. Lead zeros, those in front of a number, are never significant. So those are not. So the answer would be this has 3 significant figures. So leading zeros at the beginning of a number are never significant. All non-zero numbers are significant. Boy, I'm so glad I got this tablet and mastered it a long time ago. All right, let's look at continuation. Confined zeros, those between non-zero numbers, are significant. Well, I better do example D. And the question is, for D, how many significant figures are there? Well, all non-zero numbers are significant. So that's 4. 1, 2, 3, 4. Oh, look, we have a 0. And it's between two non-zero numbers. Therefore, confined, those between non-zero numbers are significant. So this 0 is, so it'd be 1, 2, 3, 4, 5. There's 5 significant figures in that number. And it's very important, you'll see this whole semester, to know when you have a number, how many significant figures there are. Now, trailing zeros, those at the end of a number, are significant if a decimal point is present. Oh, look, let's look at A. All nons, and the question would be, in A, how many significant figures are in this number? All non-zero numbers are significant. There's a decimal, magnified it so you could see it. And there's a 0 at the end of a decimal point. So that would be significant. So we have 1, 2, 3, and the answer is this would be 3 significant figures. Now, trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. Well, I better write one. Then the question is, in E, how many significant figures are in this number? And that's the skill hint. That's the skill you should have. Big hint. And all non-zero numbers are significant. 1, 2, 3, 4. Trailing zeros, no decimal. I'll abbreviate point. There's no decimal point, so these zeros are not significant because they're trailing zeros. And therefore we have 1, 2, 3, 4. The answer would be this has 4 significant figures. And let's go through this again, because repetition is good for your grade. Also, you get to learn it. All right, if I were to ask on a test, how many significant figures does the following number have? What are things you should know? All non-zero numbers are significant. Leading zeros at the beginning of the number are never significant. Never. Confined zeros, those between numbers, are significant. Trailing zeros, those at the number, are significant if a decimal point is present. If there's no decimal point present, trailing zeros at the end of a number are not significant if the number lacks, and here's the important thing, explicitly shown decimal point. And it's time for Dr. White to share the fun. But first, let me do a couple examples, and then I'll let you do one. And the question would be, how many significant figures, this one I'll do, then I'll let you do one, are in this number? All non-zero numbers are significant. Well, I'll do a couple. So this would be 1, 2, 3, 4, 5. So the answer would be 5 significant figures. And next one, how many significant figures in this one? All non-zero numbers are significant. Oh, look, we have 2 zeros. And here, let me check and make sure I didn't do my thumbs up, people. I see someone. Yep, people are answering. All right, now we have 1, 2, 3, 4 non-zero. We have 2 zeros, and notice this one is confined between 2 non-zero numbers, so that's significant. So is this one. So we have 1, 2, 3, 4, 5, 6. This would have 6 significant figures. And now this one, how many significant figures? All non-zero numbers are significant. Trailing zeros are never, not trailing, lead zeros are never significant. So this would have 1, 2, 2 significant figures. And finally, how many significant figures does this number have? Well, all non-zero numbers are significant. Here's a decimal point. And we have zeros at the end with a decimal point. And they would also all be significant. So this would have 1, 2, 3, 4, 5, 6, 7. Remember, that's how I write to 7. So you don't have to do it, but I do because I think it looks cool. Dr. White's always trying to be a cool dude. And thank you for everybody answering. Now it's time for you to have some fun. How many significant figures, and don't put it in chat, wait until I'm doing it because I want everybody to have fun doing it on their own. How many significant figures does A have? Don't put it in chat. Let everybody have time to do it. I see everybody out there using their brain. I see the wheels turning. That's a good thing. And when you're done, give me a thumbs up or smile. I think everybody's done. Let's do it. How many significant figures? All non-zero numbers are significant. 1, 2, 3, 4, 5, 6. And therefore, this has 6 significant figures. Let's let you try doing B. How many significant figures are in B? And don't put it in chat because I want everybody to have a chance to do this. I'll give you 6.75 seconds more to finish. Hurry up. By the way, Dr. White has a very slow stopwatch. All right, let's do this. All lead zeros are never significant, so these are out. All non-zero numbers are significant. 1, 2, 3. So the answer here, that would have three significant figures. Let's do another one. And the question would be, how many significant figures in C? By the way, C chemistry isn't that bad. Oh, that was awful. Actually, it's not, but I'm biased. All right, let's do it. All non-zero numbers are significant. Oh, look, a decimal point. Zeros at the end with a decimal point are significant. 1, 2, 3, and you count to 0. So the answer would be this. And finally, let me do a real fun one. How many significant figures in this number? I think Dr. White threw in just about everything but the kitchen sink on that one. Remember, hang in there. And when you're done, give me a thumbs up or smile. I see just about everybody's done. So let's do this. All right, how do we figure out how many significant figures in D? All non-zero numbers are significant. So I've got 4 there. Ooh, I've got zeros. This one's confined. This one's between 2 non-zero numbers. So is this one. Therefore, they are significant. Oh, I've got a 0 at the end, and I've got a decimal point. That's significant. So 1, 2, 3, 4, 5, 6, 7, 8. The answer would be 8 significant figures. Now, I've already talked about exact numbers, and they're discrete objects or defined quantities or integral numbers that are part of an equation. I'll teach you later on, don't write this down, How do you convert from centigrade or Celsius to Kelvin? Kelvin equals degrees C plus 273. I'll teach you that later this week or next week. And this is an exact number because it's part of an equation. And that's what we mean by integral numbers that are part of an equation. And defined quantities, 1 dozen equals 12 items. Both 1 and 12 are exact numbers because they're part of a definition. 1 dozen is 12. If you go into a supermarket, you buy a dozen eggs. I've never tried it, and don't you. Don't go to the supermarket, pull one egg out of the carton and say, I want to buy this. I don't think they'd be happy with you. So don't try it. Dr. White can go goofy at times. I just did. But anyways, those are exact numbers. Kelly, when you ask explain one more time, is that for exact numbers or significant figures?
It was for D, the last example we had done.
I'll go back and do it. That's the nice thing about being online. All right, let's do D again. And when you turn on your, thank you, make sure you mute your microphone after you ask the question. That way, if you have a dog, child, or train in the background, everybody won't hear it. All right, let's look at D. How do we determine it had 8 significant figures? All non-zero numbers are significant, which is this one, this one, and this 2. Now, zeros may or may not be significant. When 0 is between 2 confined numbers, this is a significant figure. Therefore, I'm going to go Technicolor on you, and I just did a generation gap thing also. This 0, oops, there should be a 1 there. This 0 and this 0 are significant because they're confined between 2 non-zero numbers. Now we have this 0, and notice we have an explicit shown decimal point. Therefore, it also is significant. If you haven't figured out, Dr. White's favorite color is red. 1, 2, 3, 4. This was there. 5, 6, 7, and 8. And that's how you got it. Did that do it for you? And just tell me in chat, did that clarify it for you, Kelly?
Yes.
Great. See, Dr. White wasn't lying to you. All questions are good questions. And I bet some of your colleagues would have or did have the same question. By the way, I better tell you something personal about me. Dr. White hates to lose. If I say I bet, I already know I won, so never bet with me. All right, so remember, exact numbers are discrete objects, like how many people are in the room. Defined quantities, like 1 dozen is 12 items, or integral part numbers that are part of an equation, like this 273. Now, when you use significant figures in calculations, and I'm talking about multiplication, division, which you'll do in my class, addition, which you'll do in my class. I don't think we do any subtraction, but also subtraction. There's certain rules, but before we learn those rules, you have to learn how to round off numbers. And rounding off numbers is a way of deleting unwanted, non-significant numbers from a or digits really, or numbers, I'll use it interchangeably, from a calculation. And there are rules. And I'm never going to ask you what are the rules on a test, but I will ask you to use them. And test 1, 2, 3, and 4, and the final, underneath the place where you put your name, it will say, please use proper significant figures for all calculated answers. If you don't, I take off a point. So for a 5-point question and you put down the wrong number of significant figures, but you did it right, and I'll explain later how I can tell you when you did it right, I would take off, instead of giving you 5, 4. So it pays to know how to round off significant figures, numbers to the right, number of significant figures, or numbers to the right. All right, for rounding off, and you already know this, but let's go through it. If the first digit to be deleted is 4 or less, simply drop that and all following, and I'll modify this slightly. Same thing for the next one. This is from your book. If the first digit is to be deleted is 5 or greater, that digit and all that follows are dropped, and the last retained digit is increased by 1. Well, let's take a look at this. Thumbs up, people. Can you see my whiteboard? Thank you. Thank you for helping me. All right. If we had this number, which is 3 significant figures, but you had to round it off, and from now on, I'll be abbreviating significant figures SF, because Dr. White's lazy, organic chemists are. This has 3. I keep the first non-zero number, significant figure, keep the second. This is the 1 to round off. That's 6, 5 or greater. If the number is greater than 10, I'm going to drop that, replace it with a 0, and the number in front of it, I'll increase by 1. And the answer would be this. And notice 0 at the end with no decimal. No decimal. These has only 2 significant figures now. Now, if I had a similar one, how would you round this number off to 2 significant figures? Keep the first significant figure, keep the second. I want to round off to 2, so the third one I use to round off. This is 4 or less. If the number is greater than 10, I would drop that and replace it with a 0. The one in front, since it's 4 or less, I don't change. And this would round down to 170, which again is 2 significant figures. And that's how you round off. Now, if I look at the clock, first of all, see someone with a chat question possibly. I got the right answer. Guess what? Time flies when you're having fun with Dr. White in chemistry. It's time for our 5-minute break, which I get up and stretch because I need to. And I'll see you in 5 minutes, and that will be at 10:55. I'll see you in 5. And it's time to start again. If you've ever seen the old movies or cartoons where the school marm walks outside door, has a big bell, ring, ring, to get all the students into the classroom after recess, ring, ring, ring. I got to buy a belt now. All right, we're talking about rounding off. And when you round off, if you're trying to reduce a number from one value of significant figures to a lower one, and you'll learn today when you do certain math operations, multiplication, division, addition, or subtraction, you'll need to do that. So let's look at this number. And let me quick check with my thumbs up, people. Everybody see that number on the screen? 0.00. Thank you. All right. Question is, how do you round this off to 4 significant, figures? Well, you look at the first significant figures. Zeros are not. So that would be this one right here. And we want 4. So we count 1, 2, 3, 4. Now, we use this number to round off. And is that 4 or less or 5 or higher? And time's up. Hopefully you all pick 4 or less. And when you're past the decimal point, a number less than 1, this and anything else afterward, you drop. So the correct answer would be to round this off to 4 significant figures would be this. If you notice 1, 2, 3, 4, it does have 4 significant figures. And now it's your turn. Round this number off to 2 significant figures. Your turn. And when you're done, look up and smile or give me a thumbs up. It looks like everybody's done. Remember, I try and give everybody time to do something. So if you're quicker than others, please be patient because I try and do that. All right, how do you round this off to 2 significant figures? You keep the first significant figure, keep the second one. You want to round off to 2. The next one is the number used to round off. Is that 4 or less or 5 or higher? And time's up, 5 or higher. Now, when the number is greater than 10, you drop that and everything else afterward, and you convert to zeros. So this would be this number. That's how you do it. Oh, let's do another one. And why don't you round this one off? Let's call this B, to 3 significant figures. And let everybody have a couple, wait until I start talking again to put it in chat. Or if you want to go ahead, if you haven't figured it, Don't you look at the chat. All right, looks like everybody's done, so let's do it. How do you round this off to 3 significant figures? Keep the 3, keep the 1, keep the 2. Those are my 3 significant figures. And Erica, I'll get to you in a second. Let me just finish this. And here, the number to round off, the 4th non-zero or 4 significant figure is what I use to round off, or the 4th figure. And that is that 4 or less or 5 or higher, and times up is 5 or higher. So I'm going to drop this and this because the number is greater than 10, replace it with zeros. This one I'll increase to 1. And notice this has 1, 2, 3, trailing zeros, no decimal point, are not significant. So this number now has 3 significant figures. Now, I think it was Erica had a question.
Yeah, I had a question on the prior one on your 600. Sorry.
Yep. You don't have to ever say sorry unless you throw something at Dr. White.
All right.
Can't because I'm on the other side of this camera.
Yeah, you had it at 15. But it shouldn't it? You said to raise it
now, hold
greater
on.
than 10.
Let's do this again. And thank you for your question. All question. Here's the number. You want to go to 2 significant figures. You keep the 1, keep the 5. Notice this number is greater than 10. And therefore, the number you're going to use to round off is this. Is this 4 or less or 5 or higher? And times up, 5 or higher. And therefore, you're going to drop that. And I think I made a mistake. Oh no, Dr. White made a mistake.
Yeah, that's why I was
I'm going to go home. I'm leaving. Goodbye. No, I'm not. Thank you for pointing that out. It should have been. And once in a while, I will make a mistake. This would be the correct answer. And thank you very much for correcting me. Time for Dr. White to look. Oh. But like I said, the first day I make mistakes. I don't walk on water unless it's frozen. Even then I don't. Quick Dr. White story. I was taking an advanced class in calculus, and the professor, this is the old classrooms where you had the sliding boards that go up and down, and you had 6. And he's using advanced calculus to calculate the formula in geometry, the area of a circle or a sphere or something that you already knew the formula, but he was showing how you could do it in calculus. And he had all these 9 boards covered. And after 35 minutes of an hour lecture, 50-minute lecture, he came to the answer. It was wrong. Everybody, and he's saying, where did I go wrong? And we're looking at all the boards. And there are about 200 people in the lecture. And after about 5 minutes, he stopped and said, see the first thing I put on the board up there? That was stupid. That was wrong. Every one of you should have challenged me on that. And he taught us the lesson that day was, just because I put something on a board and I'm a teacher doesn't mean it's right. And it's a lesson that still is in my mind because I can close my eyes right now and I can picture that white boards or the boards, they were chalkboards then. And that professor, that was Dr. Pearson. He was known as Machine Gun Pearson because he talked super, super fast. I mean, like you hear that commercials where a guy talks a mile a minute, he talked like that normally. But thank you. All right, let's see. Did I do this one right? I did. All right, let's do one more. Round this off to 2 significant figures. Let's see if Dr. White can do it right too. Uh-oh, I'm up to the challenge, I hope. I can hear the wheels turning in everybody's brain. If I look at everybody with cameras on, I don't see any smoke coming out of your ears. That's a good thing. So I warn you, I do have a sense of humor and I do use it. All right, when you're done, give me a thumbs up or look up and smile or some other indication. All right, I think everybody's done. Let's do this. We want to round this off to 2 significant figures. Notice this number is less than 1. The lead zeros are not significant. So the first significant figure is 5. The second one is 6. Therefore, we use the 7 to round off. When the number is less than 1, this is 7. Is that 4 or less or 5 or greater? 5 or greater. So I'm going to drop this and everything that follows. That's for when the number is less than 1. And hopefully I'll do it right. Increase this by 1. And that should be your answer. Notice that has 2 significant figures. Let's do this again. Round this off to 3 significant figures. Erica, I'll get to you again. I made a mistake again. Oh no. But anyways, let's do this one and then all right, real quick question. Everybody done? Yep, I think everybody's done. Let's do this and then I'll answer your question, Erica. All right, how do you round this off to 3 significant figures? Lead zeros are never significant. Notice this number is less than 1. Therefore, the first significant figure in the number is 1, then 3, then 3. I have my 3 significant figures. The next number I use to round off. I like to put the little squiggly lines under the round off number. And notice, is this 4 or less or 5 or greater? Times up, 4 or less. Since it's less than 1, I'm going to drop that and everything else afterward. And therefore, this is the number I have. And notice that has 3 significant figures, 1, 2, 3. All non-zero numbers are significant. Lead zeros are not. And that's how you do it. And I'll answer that question.
Oh, I just wanted to see if you could show us an example with a number with a decimal like in between, like at the end
Good
or in
point.
between.
Thank you.
Yeah.
Thank you very much. And the answer is yes, I can. Why don't you round this off to, oh, let's do 4 significant figures, and then we'll do another one. And this is a number greater than 1, not greater than 10 too. So why don't you round that off to 4 significant figures? Aren't you glad Dr. White encourages questions? And I even answer them too. Unfortunately, I found out feedback from many students, a lot of faculty don't do that at various schools. Sad, but true. All right, I think everybody's done. How do you round this off to 4 significant figures? You keep the first significant figure, the second, the third. Oh, a decimal point, but this is my 4th one. Now, notice the number I'm going to use to round off is past the decimal point. It's a 1. Is that 4 or less? Time's up. It's 4 or less. So I'm going to drop that, just like anything past the decimal, and the 0. And this would be 3.657, rounded off. And notice it has 1, 2, 3, 4, 4 significant figures. Oh, let's do another one. These are good. Round this off to 3 significant figures. And when you're done, smile in your camera if it's on, or give me a thumbs up. I see some smiling faces out. Oh, not this school, but the other school, assistant deans sent around stuff people put in their syllabus for VCM courses, which I thought were, oh, give me a break. And one of the things one faculty's put in, you can't wear pajamas for VCM. Who cares? As long as it's legal in the state of Illinois. Also, another faculty member, no students are allowed to be in a VCM class if they're sitting in a bed. I don't care. You're comfortable. By the way, Dr. White, and I'm going to really show my age. I have a water bed. I've had one since 1972. If you've never been on a true water bed, you're missing something great. They're fun, they're comfortable. All right, let's get back to chemistry. Round this off to 3 significant figures. First non-zero or significant figure, 1. There's a decimal point. Therefore, this 0 is significant. This 5 is. We use this to round off. Is that 4 or less? Yes. So that means I'm going to, because this is past the decimal where we're rounding off, I'm going to drop the 0 and all of this, and the number would be 1.05, which is 3 significant figures. The 1 is significant. There's a decimal. Therefore, zeros where there's a decimal are significant, and the 5 is significant. And that's how you do it. All right. Now, one of the things I will ask you to do during my class is ask the following question. Why am I learning this? And the answer you probably have is, well, I want to get a good grade on the test in the final, so I get a good grade in this class because I need it for a school or program I'm trying to get into. I bet a lot of you are into nursing. How many of you are, let me do something real quick. How many of you are planning on a career in nursing? Give me a thumbs up if you don't mind. Or nutrition or other health related stuff. Most of you are, I bet. Now, quick public service announcement from Dr. White. Dr. White writes letters of recommendation for students to get a high B or an A. If you get below that, I really can't, because I can't be honest in the letter, something that helps you. Now, for those of you going to nursing, just about all the major nursing students know Dr. White. Why? Because I write letters of recommendation for my top students. I'm always honest. If I write a letter of recommendation, I'm going to do a good job, and my students get into those schools. And the people at that schools, like UIC Nursing and Elmhurst and others, have written back to me, the faculty, can you send more of your students? Because for some reason, nurses and doctors too think chemistry's hard. It's not, it's fun, but don't tell them that. Because when they see my letter, they go, ooh, we got to get the student. So that's another reason to get a good grade. But the question is, why learn this stuff? Well, let me give you a reason. Many years ago, I worked for a company, CHEMI, which is now Akzo Nobel, an international chemical company. It's a Dutch company mainly. I went to Netherlands a lot, fun place to go to. But anyways, and part of my job was when there was a problem at some of our plants, the area I was responsible for, I was a research and development manager, senior manager. My job was to go there and solve the problem. And sometimes the problem would be the starting material, the stuff we use to make our product, had problems with it. And I'd go back to our supplier and work with them. They say, here's your problem. And most of the times I could tell them how to fix their problem, which made my life easier and my company's life. Well, one of those companies was Unichem Chemicals. And they bought a company, facilities in the Chicagoland area. They were originally in New Jersey. And when they did that and they came here, their laboratory manager was retiring. They were looking for a new one. So they knew about me and liked me. And they came to me and said, would you be our lab manager? I said, no, I got a job. I enjoy this. And then they made me an offer I couldn't refuse. They doubled my salary. I was making a darn good salary at Akzo, but they doubled it. Now I was making a real good. So I went to I worked for that company. Well, now I'm at this company that's selling chemicals to a company I used to work for, that knew me quite well. I knew all those people. Well, every chemical that's shipped has what's known as specifications, certain parameters you measure to make sure it's the right stuff. And one of those, which I really won't teach what it means, is called Iodine Value Iv, which these were fatty acids, is a very important thing. And the contract for this one product that we sold to Akzo was the IV had a minimum of 95. And that's how it was written in the contract. Well, one day, and by the way, anytime you ship something from a company, chemicals to another one, there's an important document called the Certificate of Analysis that the laboratory manager has to sign off on. And it certifies these are the parameters in the contract, and these are what we measure. Now, the contract 95 is two significant figures. When you measure iodine value IV, you can actually get three significant figures in your measurement. So we shipped something that was 95.4, which was still lower than I wanted it, but we had to ship it. How much? 4 tank wagons. If you're not familiar with what a tank wagon is, that's the big vehicle that delivers, like you were familiar with, gasoline to gas station. I think you've all seen that. Those are standardized, 40,000 pounds, 5,000 gallons. So we're talking about 160,000 pounds of chemicals being shipped, and that's a lot of money, over a couple $100,000. Well, the QC manager, quality control manager, when you get a shipment and you measure it to check that what they sent you was really correct, because even though you have a certificate analysis, you still check it. That's standard. Well, they got 94.7. And let me go to the whiteboard. We shipped, I think it was 95.3 or 95.4. They got 94.7. The contract said 95. Now notice this is two significant figures. If you round this off, you get 95. This is 3, you round it off to 2, you get 95. And this is the minimum. You have to have 95 or higher. Well, on the phone, I called the QC manager of the plant we were shipping to, which is Morris, Illinois, who knew me quite well. We'd worked many years together, where I helped solve his problems when I worked for that company. Now I work for a company. They called me up, I'm going to reject these tank wagons because it doesn't meet the standard. I said, you can't. He said, I can. I said, you can't. You have a copy of the contract in your office. And lab managers and being the lab manager at Unichema, where we were shipping it, I was both the research manager and the lab QC quality control manager. I'm one of the few PhD research chemists who was also ever a QC manager. And he had a copy of the contract, and he pulled it out, and I said, what does your contract say? 95 minimum. I said, that's what mine says. So you agree the contract says 95 minimum? He said, yeah. I said, how many significant figures is that? He said, 2. Well, guess what? You round your number off to 2 significant, you have to accept it. Well, legally he did, but he was quite mad at me. He let me know on the phone in no uncertain terms. I'm not going to let you know some of the words he used, but he was pretty upset. And I said, well, you got to accept it. Now, let me call you back. The first thing I did, I just went to my boss, and I was upset. And I brought in the production manager for that plant. And I said, from now on, anything we ship to Axo, if we get less than 95.6 IV, I'm not going to allow it to go out the door because I won't sign the C of A. Well, the plant manager got real mad at me. And my boss said, no, Dr. Weitz, we shouldn't play that game. And then I got back on the phone to the QC manager at Axo, and I apologized to him. And I said, I've set in motion, we won't ship anything to you ever again less than 95.6. And I can guarantee it because I signed certificate analysis. And then something you do in business. I said, next week, are you available for lunch? He said, yeah, let me take you out and we can talk more about this. And I went to Morris, and here the plant I was at, my offices were 47th and Racine by White Sox Park, but I know how to get to Morris because I spent many a night and day in that plant. And I went there, took him out to lunch, got him good and drunk. That's always a good thing in business. And he was happy. He accepted my apology. After that, we didn't have any problems. But significant figures play a role in contracts and patents, and that's a true story. Also, it always helps to take someone out to dinner or lunch and get them happy. They forget they were mad. That's a true story too. Now, when we talk about significant figures and rounding off, they play a role in doing math, multiplication, division, addition, and subtraction. Everybody see the operational rules on the screen? Thumbs up, people. Yep, thank you. All right, I'll never ask on a test, but you should know how to use this, and that is for multiplication, division. The number of significant figures in the answer is the same number of significant figures in the measurement that contains the fewest significant figures. I'll say that again. The number of significant figures in an answer when you do multiplication or division is the same number of significant figures in the measurement that contains the fewest significant figures. Let me show you what that means. If you were to do this 2.0 times 2.00, what's the answer? Well, everybody knows 2 times 2 equals 4. Well, that's not the answer. Notice this number has 2 significant figures. And I'll be using throughout this semester SF for significant figures. Oh, I'm going to let you figure out, but don't say it out loud or in chat. I'll give it to you. You got 3.5 seconds to how many significant figures? 2.00. Go. Time's up. Put down your computer. Anyways, all non-zero numbers are significant. There's a decimal, zeros after. So this has 3 significant figures. Now, how do you write this? Well, which is the lower number, 2 or 3? Time's up. So your answer should have 2 significant figures because the number of significant figures in the answer is the same number of significant figures of the number you're multiplying or dividing that has the fewest. So how do you write 4 as 2 significant figures? 4.0. And that's how you do that. And same for multiplication or division. And let's look at the example 4.00 times 4.00. And I didn't do it. And when I don't do it, everybody see that on their screen now? Thank you. And the answer is, well, 4 times 4 is 16, but this has 3 significant figures. This has 3 significant figures. Therefore, our answer, the lowest number of these two is 3, has to have 3 significant figures. It's a multiplication, and your answer has the same number of significant figures as the number you're multiplying and dividing that has the lowest. So this should be 16, but no, you need 3 significant, and you just pop a decimal point and a 0, and now I have 3 significant figures. Now, let's look at real life. And the question is, what's the answer to that with proper significant figures? Now, one of the things I'll be doing in the lecture is instead of using a calculator, which you can't see, I'll use the spreadsheet. But you should be using a calculator. Next week, either Monday or Wednesday, probably Monday, I will teach you how to use a calculator with scientific notation. But for now, hang in there while I open it up. Forgot to pin it on. Here it is. Thanks. Give me a second. All right. If you did this on the calculator, you're going to get something similar. 3.45 times 17.38. And then my calculator gives me this number. Remember, we're multiplying 3.45 and 17.83. Ignore the zeros here because I have it formatted. So this one, how many significant figures should my answer be, and how do I round that off? This has 3 significant figures, 3.45. 17.38, forget about the zeros right now, has 4, which is lower. 3 significant. All right, this has 4, this has 3, forget about the zeros. Therefore, I have to round this off to 3 significant figures. I keep the 6, I keep the 1, I keep the 5, and I use this to round off. That's 4 or less. And notice it's past the decimal point. I'm going to drop that and everything else. And the correct answer, which this should be 61.5. If I go back, and notice this is 3 significant figures, 4 significant figures. And therefore, when you multiply, the number should have the same number of significant figures as the number with the lowest, which is 3 significant figures. Erica, go for it.
Will we always round to the lowest significant figures when we multiply and divide?
That's a good observation, and you're correct. Excellent. I never thought of that. I'm going to use that. I'm going to steal that in the future. Will you allow me to steal that?
Go ahead for it.
Thank you. So that's how you do it. Now, if you were to put 6.15 and the rest of the numbers, an answer, like if I asked you to do this on a test or you had to do it for a formula, I'd take off -1. I'd put -1 SF if we're in a classroom on your test. But since we're online, instead of say if it were 4 points, you'd only get 3 points because you didn't have the proper significant figures. Let's do another one. Now, when you're doing scientific notation, this and this has no role in significant figures. And let me show you that. So the question would be, what's the answer of 1.65 times 10 to the third times 2.3 times 10 to the fourth? Now, next week, I'll show you how to do this on the calculator, but today I'm going to do it on my spreadsheet. Now in a spreadsheet, we put in the letter E on your calculator. That's 10 to the third times 2.3 E 10 to the fourth. And I get a hash. I see what I didn't do right. All right, hang in there. And this is the number my calculator would give me. And you get something similar. So your calculator would give you this number. And the question is, what do you do? Well, as Erica, you get your final answer has the lowest significant figures based on numbers you're having. This is 3 significant figures. This is 2 significant figures. Which is lower, times up, hopefully you pick 2. So now you have to round this off, 3.795 times 10 to the 7th to 2 significant figures. I'm gonna let you try that on your own first. Round this number to 2 significant figures. Bet they didn't warn you I make you use your brain in my class. Actually, it makes you feel part of it, and hopefully I'll help you get the hang of this better too. And when you're done, look up and smile or give me a thumbs up. As I look out into the crowd, I see everybody's done. So let's round this off to 2 significant figures. Why? Because when you're multiplying or dividing, your answer should have the same number of significant figures as the number that has the fewest significant figures. So I keep the 3, keep the 7, use the 9 to round off. Notice this is past the decimal point, and therefore this is 5 or higher. I'm going to drop this, increase this by 1, 3.8. You never change this times 10 to the 7th. And that would be the correct answer for that answer, that multiplication using significant figures. Now, if you do division, and the question would be, what would that be? Let's go to my calculator, my spreadsheet, courtesy of Bill Gates and Microsoft. By the way, I've thought about it. I've been using a spreadsheet since, I think, 1983. I shouldn't have said that. Oh. And here's what my calculator gives me. If we come back here, what the calculator gave me was this. That's a lot of significant figures. 1, 2, 3, 4, 5, 6, 7, 8. But what would be the right answer? The answer is when you're doing multiplication division, notice we're doing it division. This has 3 significant figures. This has 4 significant figures. My answer should have the same number of significant figures as the number that I'm multiplying or dividing that has the fewest significant figures. If you notice here, which is the lower number, 3 or 4, times up. Hopefully you all pick 3. So I'm going to let you round this off to 3 significant figures. Your turn. Eric, I'll get to you in a second. And by the way, good news, there's no limit on how many questions you can ask in a lecture of mine. All right, let's do this first and round this off to 3 significant figures. How do we do that? Leading zeros are never significant. And notice there's a decimal point here. Keep the 3, keep the 0 because 0's after a decimal, and in between 2 non-zero numbers significant. Keep the 4. I'm going to use the 2 to round off. Is that 4 or less or 5 or higher? 4 or less. It's past the decimal. So I'm going to drop this, this, and the answer would be 3.04. And notice that is 3 significant figures. Now, Erica, you had a question?
No, you answered it for me right when you were doing it. Thank you.
Oh, see how good Dr. White is? Not only do I ask people if they have a question, I answer them. Sometimes I even do it before you even ask it. Uh-oh, awful humor. Now, addition and subtraction is different. It took me a while to wrap my head around this one. The answer has no more digits to the right of the decimal point than are found in the measurement with the fewest digits to the right of the decimal point. Now here, we're only doing past the decimal point. How many significant figures? If we're to add this up, and I'm going to do it in my head, if I make a mistake, normally you would put this down, but this would be wrong. What we have to do is only look when you're doing an addition and subtraction. But in this class, I don't think we do any subtraction. You will be doing addition. You get the same number of significant figures past the decimal point as the answer that has the fewest significant figures past the decimal. This one has 2 past the decimal. This one has 1, which is the lower number. And the answer is 1. How do you round this number off to 1 past the decimal? Anything on this side to the left, you don't change. How do you round off 0.83 to 1 significant figure? Keep the 8, look at this to round off. That's 4 or less, so I'm going to drop it, and that's how you do it. It'd be 4.8. Let me move that 8 over a little. And that would be the correct answer. And that's how you do addition or subtraction. Now, if I look at the clock, ooh, we're almost out of time. Time flies when you're having this. We only took a 5-minute break instead of a 10. That's why I end 5 minutes early. I'm not cheating out. All right, couple important things. This math stuff is important. It lays a foundation for you to build on. But next week, I think we'll be getting into real chemistry. Dr. White's happy. Math is important, but the chemistry is the fun part. Let me remind you, 1, those of you who are in section 1, I'll see you tomorrow, Thursday at 9 a.m., not 10, 9 a.m., and on the same Zoom channel. Those of you who have lab and are in section 2, PCM 02, I'll see you on Friday at 9 a.m. I'll put out emails too, just to make sure you don't forget. And the other thing is the signature form or sheet, please upload via the assignment area of Blackboard. If you're not sure how to do that, I'll be more than happy to show you my office hours or anything else. And why, time flies when you're having fun with chemistry with Dr. White. Why, this time just went zoom. Aren't you glad I'm not serious like today? I would like to talk about exact numbers. Wake up, wake up. But anyways, I'm done for today. For those who forgot, Gehen gesund is Yiddish for be healthy. And in our environment and things going on today, it's important to say, when you say goodbye to someone, Gehen gesund, goodbye. For those who have lab, I'll see you tomorrow. If you're on Thursday, for those who have a lab on Friday, I'll see you on Friday. With that, I'm done. Goodbye. Gehen gesund.